Hi, it's Professor Monty again. Let's solve some inequalities. All right, the big thing you need to remember with solving inequalities is the only time we flip the inequality, make it face the other direction, is when we multiply by a negative number on both sides, or we divide both sides by a negative number. All right, think of an inequality as a scale. One side's heavier than the other. Well, if I add 2 pounds to each side, it's still heavier. If I subtract a pound from each side, it's still heavier. If I take off half the weight from each side, it's still heavier. If I multiply each side by twice as much weight on both pounds, it's still heavier. But when I multiply by a negative number or divide by a negative number, those ideas in the real world kind of fall apart. So anyway, let's look at some examples, see how to work these out. All right, 2x plus 3 less than or equal to 7. I'm going to solve that just as I would with a regular equation, keeping the inequality facing the same way unless I do one of these two things. So I need to subtract 3 here. So I get 2x less than or equal to 4. Divide by 2. X is less than or equal to 2. That's my answer. If I were to graph this, it's going to look like this. Less than or equal to, I've got a bracket. It's going to go off to the left. That's my graph. Interval notation is going to look like this. Negative infinity to 2, and then bracketed to 2. Never a bracket of either of the infinities, negative or positive. I've got a video on solutions to inequalities and how to write the inequalities, both graphing and interval notation. You may want to look at that later. Okay, here's another one. 5 minus x less than 12. Subtract the 5. Negative x less than 7. Well, that's multiplied by negative 1 times 1, so I need to divide both sides by negative 1. When I divide both sides by a negative or multiply by negative, that's when I flip the inequality. So that's going to be x instead of less than, though, it's going to be greater than 7. And so again, my graph's going to look like this, parentheses at the 7, arrow to the right, interval notation 7 to infinity, parentheses both sides. Okay, so that's the idea. I'm going to go from there. This one is called a compound inequality. I'm trying to get x by itself in the middle. I'll have students that will add 3 to all these, and then they think that side just disappears. That's not how it works. You need to get x by itself in the middle. X is going to be between two numbers. So just concentrate on this. Well, I'm going to add 1. Well, if I add 1 there, let's add 1 here and add 1 here. So now I get negative 2 less than 4x less than or equal to 16. Divide by 4. It's a positive 4. I don't need to flip the inequalities. If I was dividing by a negative 4, I'd flip all my inequalities. But I'm dividing by a positive 4. So I don't have to flip anything. Well, that reduces to negative 1/2 less than x. That reduces to 4 less than or equal to 4. Graphically, I'm between negative 1/2, positive 4. Bracket at the 4 because it includes it, parentheses at the negative 1/2 because it doesn't. Interval notation looks just like that. Negative 1/2 to 4. Bracket, always make sure in interval notation these are one's smallest to largest, especially with the infinities. You'd never go 2 to negative infinity, for instance. Okay, so practice these, work with these. I didn't say all the times you don't flip the inequality. Just remember the times you do flip the inequality, and I think that'll make it as easy as possible.